Okay, continuing work on alkenes. Now it's their turn to give us names and our turn to draw. And they start off pretty tame. Hept2-ene. Hept means 7. 1, 2, 3, 4, 5, 6, 7. Now, if we're going to make any kind of molecule out of these, they have to be chained together. So we'll get single bonds on all of these just to make sure this doesn't fall apart on us. And now they tell us it's an ene, so there's a double bond. Where? On carbon number 2, or starting on carbon number 2. So not here, starting here. That's hept2-ene, and that's it. There's no branches or anything else, so that's all that means. This one's a little spicier. Oct1-ene. So remember, the most interesting part of a name at first is the primary chain, and that's at the far right. So when you first see the name of a molecule, home in on this. When I look at this, I see blah blah blah. Get to it later. Oct1-ene, and that's where you want to start. Oct means 8. 1, 2, 3, 4, 5, 6, 7, 8. There have to be at least single bonds here, so I'm just connecting those. And now they say on the very first carbon is the double bond that makes it an alkene. So there we go. That's oct1-ene. Now, dimethyl means there are 2 methyl groups. Where are they? On carbons 6 and 7. So 1, 2, 3, 4, 5. Carbon number 6 has a methyl group on it. Carbon number 7 also has a methyl group on it. If you want to go 2 up or 2 down, that's no big deal. And yeah, that should do it for that one. Draw line structural formulas for each of the following compounds. Okay, so blah, blah, blah. But1-ene is the part we want to start with. But is 4, so 4 carbons all in a chain. On the first carbon is the double bond, so there we are. That's but1-ene. Now a methyl group on carbon number 3. 1, 2, 3. Methyl group. Okay, now that's the structural formula, but they want line structural, meaning they don't want to see letter C's, they just want the bonds. So we have a carbon, and on the other end of it, and between them a double bond, and then another carbon. That means your first, make these a little heavier. That double bond in line structure is drawn like this. So there's a carbon on this end, there's a carbon on the other end. After that, we have this single bond. Get that kind of neat shape. Then another single bond. Okay, so that's our but1-ene. 1 carbon, 2 carbons, 3 carbons, 4 carbons. And then on carbon number 3, 1, 2, 3, we have our methyl group coming off. So probably like that. For this, blah, 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 stuff I don't care about right now, hept1-ene is where you start this. 7 carbons. 1, 2, 3, 4, 5, 6, 7. On the very first carbon is our double bond. There we go. That's hept1-ene. Now, on the second carbon, put an ethyl group. Done. On the third and fourth carbons, put methyl groups. Carbon there, carbon there. So there's our structural. Now, if we do this with lines, we have a double bond first. So for this, it's like you're drawing the double bonds and just skipping the carbons. Do you have to start going up? No, I think I always do. It's just a habit I have, but it doesn't really matter what your first angle is. So that takes care of this. Then we have 1, 2, 3, 4, 5 more bonds to worry about there. 1, 2, 3, 4, 5. Remember to zigzag so it's easier for people to count how many atoms you're declaring here. We have a double bond coming off carbon number 2. So there's that and that. And we have a single coming off carbon number 3. There we go. And we have a single coming off carbon number 4. There we go. Of course, the colors are not necessary. I'm just hoping it makes it a little easier to follow what pieces of this diagram correspond to which pieces on the line diagram. Probably didn't need it for this one, but as they get more complicated, you might find you appreciate that. So I will probably keep doing it if I think we have an ugly molecule. Speaking of ugly molecules, 3-ethyl 4,5-dimethyl hex 1-ene. Start on the right. Hex 1-ene means carbon 2, 3, 4, 5, 6. The first one is where the double goes. The third one gets an ethyl group, and the fourth, I'll just go up for all of them. It's a little unrealistic, but I don't have a lot of space below, so I have to make it work somehow. Okay, so how do we build this? All these bonds are the primaries, so we start with the double. 1, 2, and then 1, 2, 3, 4 singles after that. 1, 2, 3, 4. Now, because I don't trust myself, just allow me to count that. 1, 2, 3 carbons, 4, 5, 6 carbons. That's hex. Okay, good. I didn't make a mess there. And what else has this thing got? We have an ethyl group coming off carbon number 3. So 1, 2, 3. From here we have 1. I'll bend it that way. What the heck? Okay, there's our ethyl group. And then off the next 2 carbons we have methyl groups. So this gets a methyl group, and so does that. Here I drew them both up because I kind of needed the space. Here, because I had a little more space, I did the more correct thing and had these pointing out away from the primary chain. These electrons repel each other, so they will normally try to stick out as much as possible rather than being jammed into an angle like this. They'd rather be out away from the other atoms. Not a critical detail for a diagram like this, but it is true, and it's a good habit to form if you're going to be drawing molecules more in the future. And guess what? You will.